Bismillahirrahmanirrahim. In this video, we'll be discussing end chapter question 9.19, and this is for students who are beginning to learn network analysis, especially from Mr. Alexander and Sadiku's book. So let's see. Using phases, find the summation of these here. So we will solve one at a time. This is the first question. Now we know to convert into phasor, we need to have in cosine form. So it is already in cosine form. And this is how we go about. If it is Vm cosine omega t plus phi, in phasor domain or phasor form আমরা লিখে নেব bold V অথবা I'm sorry, in phasor domain, we can write it as a V bold and Vm, the magnitude, and angle theta or phi. So from here, we can directly convert this magnitude and angle into phasor form. Similarly here, minus 5 and angle minus 30. Now to add, we need to convert these into rectangular form. And I hope by now you have learned how to convert from polar to rectangular and rectangular to polar. If you have difficulty, I have a video on this. So you can look for that. Okay, so converting into rectangular, we get this. And similarly, the second part. And now we can add the real part and the imaginary part. Adding, we get this answer. And this is in rectangular form. Now we want to go back to the time domain. For that, we have to, first of all, convert this into this form, polar form, and then go back to time domain. So let's see what will be the answer in polar form. So this is in polar form. We have magnitude and we have angle. And so in time domain, converting back into time domain will be this magnitude cosine of 20t. 20t is the value given here in the signal. So we'll write 20t. And this angle 114.49. So this is part A. And we can write final answer, question equal to this answer. Then the second part, similar, but here we have a sine signal. We got to convert it into cosine. And from sine to cosine, we can convert by subtracting 90 degree. So we subtract 90 from the first one, and we change sine into cosine. The second part is cosine, so nothing to do. And now we can convert into phasor form. So magnitude and angle minus 90. Here 30 and angle minus 45. And to add here also, we have to convert it back into rectangular form. So this is rectangular form. We add the real and imaginary parts. Adding the imaginary, the real remains just one. So this is real, and adding these two, we get this value. Convert it back into polar. In polar form, we get this answer. And now back into the time domain. Magnitude cosine of 50t now, because 50t is in this question. So we'll write 50 and minus this angle, or plus minus 70.89. So this is the answer. And final answer we can write like this. Then coming on to part C, this has 3 parts. And you can see there are 2 sine signals. This is sine and this is sine. So as we discussed, we have to convert sine into cosine by subtracting minus 90. So from here, subtracting minus 90, we converted sine into cosine. This is cosine, so nothing to do. This is sine, so here also will change to cosine and minus 90 from this angle. Now this solving, we get minus 110. And now we can write in polar form or phasor domain, the magnitude and angle, magnitude and angle, and magnitude and angle. Now to add, we have to convert into rectangular. So converting these into rectangular form and adding the real part and imaginary part. So this is our answer in rectangular form. Now we have to go back to polar form. So this is the answer in polar form. And from here, we can now go back to time domain. So the answer will be converting back into time domain, 9.44 cosine 400t, because 400t is in this. 400t minus this angle, 44.7 plus minus 44.7. So it will become minus 44.7. And the final answer question is equal to the answer. I hope you have been able to follow this. Please let me know through your feedback. Thank you.